IUPAC nomenclature. Before starting IUPAC nomenclature, we have to know the trivial names. Actually, these are naming from the source. As for example, say this is acetic acid. Really, this acetic acid is coming from acetum vinegar. And that's why it is called acetic acid. This is malum, apple. This is malum, called malic acid. Wood spirit, after distillation we get methyl alcohol. This is wood spirit. This compound is originated from urine. That's why it is called urea. Oxalis plant, oxalic acid is originated from oxalis plant. That's why it is called oxalic acid. So from the source we can name the compound. This is the trivial names. Now IUPAC, International Union of Pure and Applied Chemistry. First of all, we have to know the rules. Word root. What is word root? It is the number of carbon atoms present in the longest chain possible. That is called word root. As for example, say C1, we call it methane. Actually, methyl, C2 is ethyl, 3 pro, bute, pent, hex, heptoc, non-dec. 11 is undec, 12 dodec, 13 tridec, tetradec, pentadec, hexadec, heptadec, octadec, nonadec. Icosa or icosa, it is anicosa. 22 is biicosa, 23 triicosa, non-icosa, tricont, tetratricon, this is tetracont, hexatetracont, C50 is pentacont, C60 is hexacont, and in this way, C80 is octacont. So these are the main word root. Next, suffix. The word root is followed by a suffix or suffixes which represent the nature of CC bond. That means it may be double bonded, single bonded, etc. But suffix of two types, primary suffix and secondary suffix. Primary suffix is practically it is added after word root to indicate the saturation or unsaturation present in the chain. Say this is CC, it will be N. C double bond C, in, triple bond C, ein, right? This is IL. 2 double bond diene, this is diene. Okay. And one important point is an extra A is to be added after word root if primary suffix begins with consonant. That is other than A, I, O, U. As for example, this is diene, diene with the word root. So butadiene is wrong. Butadiene. So A is to be added. Butadiene is the correct one. Next, secondary suffix. It is added after primary suffix to indicate the nature of function group by removing E if secondary suffix starts with vowel or Y, and terminal E is retained if secondary suffix starts with consonant, except A, I, O, U or Y. As for example, say it is N, starts with A, butanol is wrong, E is to be omitted, butanol, right? Propane, A, weak acid, propane weak acid wrong, propanoic acid, but it is consonant diol, so ethanediol. E is retained. Okay. Now prefix. It is added before word root to indicate the nature of side chain or substituent. As for example, say X, it will be halo, C double OH, it will be carboxy. When it acts as functional group, it will be oic acid. But here it is prefix, that is side group, carboxy. This is methyl, ethyl, propyl. This is ester, alkoxycarbonyl, OH, hydroxo. SH, mercapto, NR2, NN diethylamine, dialkyl amino, CONH2, carbamoyl, SO3H sulfo, double bond CH2, methylidine. These are the prefix, that is side group, methoxy, formyl, COCl is chloroformyl, N double bond diazo, nitro, ONO, nitrito, that is O bonded nitro, cyano, isocyano, nitroso, ketoroxo. As a side group, NH2 amino, NHR, N-alkyl amino. This is epoxy, nitrato, and ethene. All these are acting as side group or prefix. So the total IUPAC will be prefix first before word root, next word root, primary suffix, nature of CC, next functional groups, secondary suffix. This is the complete IUPAC now. Say this is the example, C4, that is total 4 carbon atoms, that is the base chain is bute. This is the functional group, secondary suffix all. primary suffix is N because all are single bond, N. This is prefix chloro. This is the numbering 1, 2, 3, 4 because functional group is linked with this carbon. So this is 3-chloro. This is 3-chloro butanol. Butane 1-ol or butanol. Right. Okay. Now we can start IUPAC name of different systems. Say alkane. The longest carbon chain is considered as the parent chain. Right? For this one, 2, 3, 4 carbon. Here it will be 3, 4, 5. So this is the correct one. Longest carbon chain. Again, the longest chain will be that one having maximum number of functional groups. Here it will be 5 carbon. Here also it will be 5 carbon. But only one side groups, not functional group. Maximum branching is there. So if more than one option is possible to consider the longest chain, that will be the correct one which has maximum branches. Here maximum branching. First one, second branch, this is the ethyl branch. So 3-ethyl, 2,2-dimethyl pentane is the correct one because number of branching is maximum. Numbering starts from that end, which is the nearest of branch. Obviously, this is the branch, so it will be 1 and 2. It's wrong. Next, for multi-branch system, that numbering scheme will be preferred where sum of branch number will be minimum. Say for this compound, it starts from this side, so it will be 2 and 4. 2 methyl groups are linked with 2 and 4 carbon. So branch number is 2 and 4, sum is 6. But if its numbering starts from left side, branch number 3 methyl, 5 it is another methyl, so number 3 plus 5 is 8. So this is higher than 6. So this is the correct. It will be the correct. Minimum number will be the correct. If there are 2 or more substitutions, naming follows alphabetical. Obviously, this is methyl, this is ethyl. So ethyl should be named first. So 3-ethyl 2-methyl hexane. This is the correct one. Okay. Now unsaturated hydrocarbon. If the position of double bond and triple bond is not same, numbering starts from that end which is nearer to the double or triple bond. Say here it is starting carbon is double bonded. In this case, starting carbon, second carbon is triple bonded. So starting one will be starting here. So that is double bond gets more priority over triple bond because there 2 carbon is linked with triple bond. So this is the correct one. But name is ended by ine always. So this will be pent 1 in 3 ine. It is wrong. Okay. Now, if the position of double bond, triple bond is identical, then double bond gets more priority for numbering. But name is ended by ine. Here it starts double bond, triple bond starts in 1. Here double bond starts also from 1. So anyone can be right. So this is wrong. Triple bond gets more priority. This is the correct one. Double bond gets more priority for numbering. So it's the paint, but 4 ine will be in last. So paint 1 in 4 ine is the correct now. Correct naming. Double bond, triple bond, bonded group may act as substituents also. Here it is the double bond. So 1, 2, 3 position, here also 1, 2, 3, but this is the methynyl, methylidinyl or methinyl. So this is 3-methylidinyl or simply 3-methinyl, paint 1 for diene. This is ethinyl, ethylidonyl or ethinyl. 3-ethinidyl or ethinyl, paint 1 for diene. Now, if the compound have different types of functional groups, the relative sequence is this. Carboxylic is maximum, next sulfonic acid, next ester, acid halide, amide, cyanide, isocyanide. So this order should be kept in your mind, should be memorized. Okay. Now, in IUPAC, different functional groups is named in this way. So this is alcohol, it will call alkanol. Ketone is called alkanone. Amide is alkanamide. Acid anhydride, alkanoic acid anhydride. Ether alkoxyalkane. Nitro is called in IUPAC nitroalkane. Thioether, alkyl thioether, acid halide, alkanoyl halide. Acetaldehyde is alkanal. Carboxylic acid is alkanoic acid. Amine is alkanamine. Ester is alkyl alkanoate. Nitrile is alkyl nitrile. Halide is haloalkane. And thiol is alkene thiol. So these are the IUPAC naming of different functional groups. Now we start alcohol. 2-carbon alcohol, this is ethanol common name. IUPAC name is also ethanol. This is SHOH, priority starts from OH. That's why numbering starts from 1 that is linked with OH. So this is 2,3-dimarcaptopropanool. SS side group markup to 2,3-di markup to propanol. It is called British anti-leucite. Market name. Now here it is 2 carbon is linked with 2-methyl. So this is 2,2-dimethyl propanol. Okay. Next here we see this is pentyreitritol. This is the common name, nickname. But at 2 position, hydroxymethyl, 2-hydroxymethyl are linked. That's why 2,2-bis hydroxymethyl prop 1,3-diol or 1,3-propanediol. Right? This the common name is pentyreitritol. This is glycerol 1,2,3. So it will be propane 1,2,3-triol. This is ethylene glycol, ethane 1,2-diol. Very simple. Now aldehyde ketone. 1 carbon aldehyde, formaldehyde, methanal. This is ethanal. 1, 2, 3, 4. Butanal. Now here it is keto, it is aldehyde. Aldehyde gets more priority than ketone numbering. That's say 1, 2, 3, 4. 3-oxo or 3-keto. This is the side group. 3-oxo butanal or 3-keto butanal. Both are right. This is 2-prop-2-one or 2-propanone. Now this is symmetric ketone. 2,3-dione, but 2,3-dione, both are functional group. Both are aldehyde, 1,2-diol, ethane 1,2-diol. This is glyoxal. This is pyruvic aldehyde. Aldehyde gets more priority over ketone. This is 2-oxo 1,2,3, propanal, 2-oxo-propanal, pyruvic aldehyde. Okay. Next here we see is the another aldehyde is a side group. Formyl is called aldehyde. That is the prefix. So 2-formyl butane 1,4-diol, butanediol or 1,4-butanediol. 2-formyl butanediol. This is 1, 2, 3. Aldehyde gets more priority. 2 position is linked with double bond. Prop 2-in-1-L. This is acraldehyde actually. Acraldehyde. Prop 2-in-1-L. Now carboxylic acid. 1 carbon carboxylase is formic acid. In IUPAC it is methanoic acid. This is ethanoic acid. 2 carbon are practically COOH. So this is ethane dioic acid. That is oxalic acid. This is common name. Now here we see at 2 position, 4 position, 2 different groups. There is methyl, this is hydroxy. 4-hydroxy 2-methyl pentanoic acid because the base chain is pentanoic acid. Here one interesting point is 1, 2, 3, 4, 5, maximum 5 carbon atoms in straight chain. But the point is this is very, very important rule. When an unbranched carbon atom is directly linked to more than 2 like functional groups, then it is named as the derivative of parent alkane. Mind that this is acid. 2 position is linked to acid, 3 position linked to acid. The same functional group unbranched carbon and linked with these three carbon center. That's why these 3 carboxylic acids are the derivative of this main 3. So it will be 2-hydroxy propane 1, 2, 3 tricarboxylic acid. Unbranched carbon atom is directly linked with more than 2 functional groups. Then it is unbranched. There is no branching. These 3 carbon, same functional group, but more than 2. That's why it is the derivative of parent alkane, the derivative of propane. But here, said it is 1, 2, 3, 4, 5. Why? Because this is carboxymethyl. It's not simply carboxylic acid. That's why it is 3-carboxymethyl. This is the methyl group, carboxy derivative of methyl. 3-carboxymethyl pentane 1,4,1,5-dioic acid or pentane dioic acid. This is succinic acid 1,4-dioic acid, butane 1,4-dioic acid. This is malonic acid 1,3-dioic acid, propane 1,3-dioic acid. Now ester, and we know for ester, this is the parent acid should be named after mentioning this alkyl group. This is methyl methanoate. A is to be added after the naming of acid. This is the acetic acid, that is ethanoic acid in IUPAC. So this is methyl ethanoate. This is formic acid, that is methanoic acid, ethyl methanoate. Right? It's a lethal format. In IUPAC, it will be ethyl methanoate. This is acetic acid, ethyl derivative, ethyl ethanoate. Now it is the acid where it is 3-keto is the substitute. So that is the functional side group, sorry. That is 3-oxo or 3-keto butanoic acid. It's ethyl derivative. So ethyl 3-oxobutanoate. Ethyl 3-oxobutanoate, it is ethyl acetate. It will be practically ethyl acetate derivative, but in it is the phenyl derivative of ethyl acetate, right? So at 2 position there is phenyl. So methyl, this should be named first, methyl to phenyl ethanoate, right? Now it should be 1, 2, 3 dicarboxyl, that is diethyl propane dioate. Propane dioic acid is the main original base, original acid, but diethyl derivative of ester is actually diethyl malonate. This is diethyl propane dioate. It will be butanoic acid, it's ethyl ester, so ethyl butanoate, butyrate or butanoate. It will be 6-fluoro derivative, but here 3-cyano 6-fluoro, methyl 3-cyano. This methyl should be named first, methyl 3-cyano 6-fluoro heptanoic acid, because total 7 carbon is the longest chain. Now amide, 1 carbon amide is formamide, in IUPAC is methanamide, this is ethanamide, NN dimethyl formamide, practically NN dimethyl methanamide, IUPAC. Now acid chloride should be named in this way. 2 carbon containing acid is acetic acid, that is ethanoic acid, so ethanoyl chloride, ethanoyl chloride. It will be ethanoyl, it is propanoyl bromide. This is 2-methyl butanoyl chloride. Very simple. Next acid anhydride should be named just anhydride of 2 acids. Here it is the propanoic acid, so propanoic anhydride. Because anhydride with the bifunctional groups. So dipropanoic anhydride is not to be required to mention it, because anhydride being bifunctional, so just propanoic anhydride implying 2 propanoic groups are there. It is ethanoic anhydride. That is the anhydride of ethanoic acid. This part is ethanoic, this part is propanoic. So ethanoic propanoic, E be the alphabetically first. So ethanoic propanoic anhydride. This will be ethanoic, this will be butanoic. So B and E, this is butanoic ethanoic anhydride. Alphabetic order is obeyed here. Next, ether. This is the methoxy derivative. This is the methoxy derivative of methane. That's why we call it methoxymethane. Commonly, it is dimethyl ether. It is the ethoxymethane or methoxyethane which is correct. The smaller group should be named first. Methoxyethane with the correct one, right? So here also at 2 position methoxy, so 2-methoxypropane, right? In this case, so this is the base part. 2 position is linked with methyl, 2 position linked with this one. So this part should be named in another IUPAC system within first bracket. So named carbon should be 1. So that group will be 1,1-dimethyl ethoxy, 1,1-dimethyl ethoxy, and it is linked with 2 and another side group. So the technique is 2-methyl first prefix, 2 within first bracket. This is the IUPAC, 1,1-dimethyl ethoxy, base is 3 carbon, that is propane. So this methyl is the side group, this whole group is the side group, and both are linked with 2 carbon. So 2-methyl, 2,1,1-dimethyl ethoxy, propane. Very, very important IUPAC. Now a new approach, oxa style. What is this? In place of this oxygen, ethyl oxygen, we just imagine that is CH2. So here also CH2, that is the B, 1, 2, 3, 4, 5, pentane derivative. 2, 3, 4, 2,4 dioxapentane. This O group is called oxa or oxa. So it is the derivative of cyclohexane. So 1 and 4 position are replaced by oxa. So this is 1,4-dioxacyclohexane. Dioxane. It is 1,3,5-trioxacyclohexane. Trioxane. This is simply in this manner. It will be 2-oxapropane. So oxa or oxa nomenclature, just considering O in place of CH2. Next, amine. Methanamine or methylamine, common name. Methanamine or aminomethane with IUPAC. It will be N-methyl methanamine, right? It will be NN dimethyl methanamine. It will be NNN trimethyl methanaminium chloride. So this will be 1 degree, this is 2 degree, 3 degree, and quaternary. Okay, NNN trimethyl methanaminium chloride. This is nitrile, right? Cyanomethane, when it is called cyano, it is the derivative of methane. That's a cyanomethane. But when we consider nitrile, this carbon should be considered ethane nitrile. So when we just mention the nitrile style, that carbon of cyanide should be counted. So ethane nitrile is exactly called cyanomethane. This is ethane dinitrile or cyanogen gas, right? Ethane 1,2-dicarbonitrile or butane 1,2,3,4, 1,4-dinitrile or 1,2-dicyanoethane. This will be 1, 2, 3, 4, 4. So 2 poison methyl. So 2 methyl propane nitrile. Because when nitrile is mentioned, carbon of cyanide or nitrile should be counted. Here also, this is the best part. Same group more than 2. That should be propane 1, 2, 3 tricarbonitrile. This is very, very important example. Propane 1, 2, 3 tricarbonitrile. The same technique when an unbranched carbon atom is directly linked to more than 2 like functional groups, then it is named as sorry, it's named as derivative of the parent alkane, which does not include the carbon atom of functional group. This is 1,3,5 tricyano-benzene, right? Now, cyclic compound. One second. Okay, for the cyclic compound, side group is named first, then cyclo. At one position, there is propyl, that is 1 propyl cyclopentane. One may be omitted also, propyl cyclopentane, implying the carbon is linked with, that side group is linked with 1 carbon. If the side groups is branched, IUPAC naming of side group to be written within first bracket, and the link carbon should be 1. So this will be 1,1 dimethyl ethyl. This is the ethyl, and 1 position is linked with 2 methyl, so 1,1 dimethyl ethyl, and this is linked with cyclopentane. So 1,1 dimethyl ethyl. This is dimethyl ethyl cyclopropane, right? Cyclo, not propane, it will be cyclopentane, sorry, strong cyclopentane. Now, if more than 1 different substituents are there, they will be listed obviously alphabetically, and the ring is numbered in the direction that gives the lower number of lower alphabetic group. Say here it is methyl, and this is propyl. So M and P, obviously M greater than P, alphabetical. That's why numbering this order: 1, 2, 3, 4, 5. 1 methyl, 3 propyl, cyclohexane. Okay, but here is methyl, this is ethyl. E is more priority. E has more priority over M. So here 1, 2, 3, 4, 5, 6. That is 1 ethyl, 3 methyl, cyclohexane. In this case, this is ethyl. This is 1, 2, 3, 4, 5, 6 hexyl. So ethyl gets more priority 1, 2, 3, 4, 5, 6, 7, 8. So 1, 1 diethyl, 4 hexyl, cyclooctane. If the side chain contains greater number of carbon, right, then the ring attached to it will be considered as the substitution. Here the side chain is the 8 carbon, here 4 carbon. So now cyclobutane be the cyclobutane, this ring is acting as the side group. That is 1 cyclobutyl octane, or simply cyclobutyl octane. Here also is the main, this will be side. So 1 cyclopropyl 4 methyl octane, or simply 4 methyl cyclopropyl octane. Now, if the ring contains any functional group, it gets more priority ever containing lesser number of carbon atoms to the side ring. It is a functional group, 5 carbon, here 6 carbon. Still, it gets more priority. 1, 2, 3, 4, 5, and 4 is linked with this. So this is 1, 2 dimethyl, 4 hexyl, cyclopent 1 in, right? Here, this is the keto, 3 hexyl, this is hexyl 1, 2, 3, 4, 5, 6, 3 hexyl, cyclopentanone, cyclopent 1 on, right? Now, if more than 1 rings are there, ring with more carbon atoms gets more priority. So this will be the main, this is the side. So 1 cyclopentyl, cyclohexane. Now, if both are identical, any ring gets the number. So this is 1 cyclopropyl, cyclopropane. Now, nomenclature of cyclic system having common atoms. There are 2 cases: single common atom and 2 common atoms. First case is having 2 common atoms. That is bicyclic system. Numbering starts, this is the bicyclic system. Numbering starts from 1 common atom, that is the bridged atom, say it is 1, to opposite bridged atom, right? Proceeding first along the longest bridge, right? Next longest bridge, and ultimately the shortest one. Say this one. This is the bridge carbon, 3 bridge, and 4 bridge. So this is the longer. So 1, 2, 3, 4, 5, 6, 7, 8, 9. right? The bridge carbon, next the larger number of bridge, 4 carbon bridge, this is 3 carbon bridge, so larger is preferred in descending way. So here it will be 8 methyl bicyclo, here 3 carbon, sorry, 4 carbon, here 3 carbon, here 0 carbon. That's a 430 nonen. The number, descending number should be placed in third bracket. Okay, so these are the techniques. So here it will be bicyclo 221. Both are same. 221. Total number of ring carbon is 7. So heptane. Okay. Here it will be, this is 2, 3, 4. 4 carbon here, 4 carbon. 11, 11 dimethyl. Why is 11? 1, 2, 3, 4, 5, 6, 7, and 9, 10. This is 11. 11, 11 dimethyl. Bicyclo. 441. Here it is carbon. So 441 undecant because total number of carbon in ring is 11. Here it will be bicyclo 110. There is no carbon. Butane. This is bicyclo 1, 2, 3, 4. 440. There is no carbon. Decant. This is not here. Now having one single common atom, it will cause it will call spirocarbon. Say here it is smaller ring, larger ring. The numbering starts from the atom next to the common atom. This is the common atom. And proceeding through the smaller ring first, then through the common atom, the larger ring. So this will be first. Smaller ring, 2, 3, 4. It will be 5 or this will be 5, depending on the side group. But there is no side group. So 5, 6, 7, 8, 9. It will be 9. So total number of atoms will be non-n. But spiro should be mentioned because single common atom for 2 rings. Spiro 3, 5. Here ascending. Here 3 carbon. Here total 5 carbon. So spiro 3, 5 non-n. Here it will be 1, 2, 3, 4, 5, 6, 7. Spiro, this is 2 carbon. Here 4 carbon. 2 for heptane, total number of heptane. Here it will be smaller ring. So 1, 2, 3, 4, 5, 6, 7, 8. 6 poison, 2 poison are linked with cyclopropane. So 2, 6 dicyclopropyl, spiro. This is 3 carbon. This is 4 carbon. 3, 4 octane. Now certain examples for aromatic system. This is benzene. Methyl benzene is called toluene. This is 1,2-dimethyl benzene. This is halogen derivative 2-chlorobenzene, 1,2-dichlorobenzene. This is hydrogen. This is salicylic reactive 2-hydroxy toluene. This is 4-hydroxy, 1,4-dihydroxybenzene. This is actually methanol derivative, right? Phenyl methanol. This is methoxybenzene. This is phenoxy. This will be phenoxy. Phenoxybenzene. That is diphenyl ether. Now aldehyde ketone. Here it will be 2-hydroxybenzaldehyde, CHO, benzaldehyde. It will be phenyl ethyl ketone. This is phenyl ethyl ketone, right? Ethanone practically, not ketone. Phenyl methyl ketone. That is phenyl ethanone, 2 carbon atoms. Diphenyl methanone. That is single carbon diphenyl derivative. Now carboxylic acid. This is practically phthalic acid. Benzene 1,2-dicarboxylic acid. This is the phenyl derivative of acetic acid. So 2-phenyl ethanoic acid. Okay. Now different examples of IUPAC system are given here for practice. In this one, 1, 2, 3, 4, 5, 6, 7 is the longest chain. So it will be 2-methyl, 5, and 6, 6. This is 5-methyl. 6, 6, another 2-methyl. So 2, 5, 6, 6 tetramethyl, 1, 2, 3, 4 tetramethyl, hept because 7 carbon, 1 in, right? So in this way, just you practice. Different examples are given here. This is very important example. This is already mentioned. Hydroxymethyl. This is another robotic system. This is very important. But if we consider simple way, in this way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? It is the wrong because the longest chain will be that one having maximum number of functional groups. So that is the double bond here. That's why 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So these are the main longest chain because having 2 functional groups. But this 5 carbon is linked to the cyclobutane having another 2 groups. So we see in 3 position 1, 2, 3, 4, 5. So we see 3, 5 dipentyl, right? 5, this will be link carbon 1, 2, 4 dicyclopropyl cyclobutyl, Total number of carbon 9. That's a non-2,7-diene. So 3,7-dipentyl, 5 within first bracket, 2,4-dicyclopropyl cyclobutyl, non-2,7-diene. It's very, very important example. So different examples are given here for practice. We just practice it. And very simple. And all rules are completed here. Thank you.